I'm Sienna Bose. Welcome to my channel, Learning Builds Life, and today we are going to talk about isotopes. First, we will discuss about what are isotopes. Now, you know that an element, the atoms of an element all have the same number of particles. They all have the same number of protons and neutrons. Atoms of an element same number of subatomic particles. They have the same number of subatomic particles, but sometimes some atoms of an element have, like, protons are same always. Protons are same. Because if there is a difference in the number of protons, then the element changes. But there can be a little bit of difference in the number of neutrons. Protons are always same. But there can be a difference in the number of neutrons, which leads to a slight change in the mass number. Neutrons can differ in number, which leads to fluctuations in mass number. Fluctuation in mass, just mass. Because of which the different atomic forms of the same element are called isotopes. The different atomic forms of the same element are called isotopes. Now we need an example to make this concept clear. We will take the example of carbon, C. Carbon, C. There are three isotopes of carbon. The most common one, which makes them 99% of our, like the naturally found 99%, is carbon 12, or it can be written as 12 in the superscript to the left of C, the symbol, and then we have the number of protons, or the atomic number, which is C12-6. It can be written like this. This is carbon 12, which is found 99%, and the rest 1% is made up by carbon 13, which is rare, as you can understand. Carbon 13. I'm not writing it because it's the same thing actually, but I'm just writing the symbol. It's written as 13, 6, and here. In case of what's the difference in the number of neutrons, over here there are 6 neutrons. We know how to calculate the number of neutrons. The mass number is 12, and the atomic number is 6. That means the number of protons, so we need to subtract 6 from 12 to get another 6 neutrons. But over here, 13 minus 6 gives us 7 neutrons. That is carbon 13 isotope. And the most rare isotope is carbon 14, which has 8 neutrons. This is the radioactive isotope, actually. Now we have to talk about the radioactive isotope, but first let's check the difference in the number of neutrons. Here are 6 neutrons, here are 7 neutrons, and here 8 neutrons. This is, I hope this made the concept of isotopes clear. Now, we can move on to the radioactive part of C14-6. First of all, this is very rare. Now, what is a radioactive isotope, like this one? We know that C12-6 and C13-6, these two isotopes are very stable. Sorry. Those two isotopes are very stable, which means they don't lose any of their subatomic particles. 12 says carbon 12 and carbon 13 are very stable as they don't lose any subatomic particles. It's very important. This process of losing subatomic particles is called decay. But C14-6, the carbon-14 isotope, is the radioactive one, which is not stable, that loses its subatomic particles and energy. Loses subatomic particles and energy. It loses, so if they decay, the decaying of protons can also lead to any other element actually gets formed from the decaying process. That's the reason why C14-6 is really unstable. That is the radioactive isotope. I'm just writing that down. Radioactive I'm just writing that one more time. Radioactive isotope Now you may take a look at the board. We will discuss more about radioactive isotopes in the topic radioactive tracing. Let's continue with more about radioactive isotopes, radioactive tracers. Radioactive tracers. We must know one thing, that radioactive isotopes are widely used in medical science. Radioactive isotopes are widely used in medical science. We will come to that, but first we must note this, that if in a cell the normal isotope would work, the radioactive isotope would work the same way as a non-radioactive isotope would work in the cell. Hence, some radioactive isotopes are incorporated into biological fluids. which help in tracing. They help in tracing metabolism. Active tracers help trace the metabolism. Metabolism is basically all the chemical processes which happen in the body, which has to be traced. Like, for example, in kidney disorders, we inject a tiny sample of radioactive substance, which helps in tracing the metabolism in all of those, whether the kidney is forming the urine properly or not. Those are traced by the radioactive tracers, so they are very useful. But we know that radioactive substances have some issues with if excessive exposure. We will talk about that, but first let's finish off with our radioactive tracers, this concept. So as I said, it helped in tracing the metabolism in the body, and also it's the constituent part of PET scanners. Radioactive tracers are the constituent part of PET scanners because they help in tracking the growth and metabolism of cancerous cells. That's the reason why radioactive tracers are the constituent part of PET scanners. That's the main purpose, since they can track the growth and metabolism of cancer cells. Now, the drawbacks of radioactive isotopes and radioactive tracers. The drawbacks are, that hazardous, it's a health hazard. Health hazard. If there is excessive exposure. The perfect example of excessive exposure, which can lead to health hazards, is what happens in a nuclear attack. Nuclear attack. Health hazard if there's excessive exposure that happens mainly in nuclear attacks. But whatever exposure we have in medical science is mainly safe. It's safe for us, hence it's used in medical science. Otherwise, what they use? Health hazards if there's excessive exposure. And that happens in nuclear attacks. But for medical science, it's okay. It's safe for us. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe to my channel, and stay tuned for more videos. Thank you.